Hi everyone, happy Sunday. In the last post, I spoke about data fabric. The and came up with an analogy of how data fabric is in relation to the services that built on top, as well as the endpoints and how the endpoints are related with each other. One concept that data fabric is based on is the data catalog. And data catalog is the system of meanings or metadata that business can find their way around the data to find their requirements or their query with the speed, with clarity, and with the accuracy that they require. Data catalogs are these days are based on graphdb, and the subject of today is we are going to do some hands-on exercise as to what graphdb is, how it works, how easy is this to build, what is the language, what are the commercial graphdbs in the market. Those things we'll cover. So let's go right into it. I'll share my screen. 4J is a commercial graph database, is the most established one around in terms of work. It's been since 2007 they've been doing this. This is their sandbox online connected to their database service on the cloud, which is called Aura. So I've created already username and password and I'm there. Let's see what we have in this database of mine that is recently created. Match and return in. Okay. So we only have two nodes and one arrow. Okay, two nodes and one arrow, one relation. So this basically match and return, and similar to, let's say, select a star from user tables in Oracle or MySQL. Now let's get rid of everything and create a couple of new nodes here from scratch. We say match. First we detach all the connections and then we delete them. That's as simple as that. Two nodes and one relations are deleted in 2 milliseconds. Let's see what we have here now. We don't have any node or relation. We start creating some node, then run a script that creates a whole bunch of nodes for us. Okay, let's create a vehicle first. As soon as we enter the semicolon, the list of existing node types are appearing. If you see, as soon as we go to enter, there are movie and there are person. These are the default node types. We create a new one, vehicle. Then let's add some attributes to it. Name, which is truck one. Okay, truck one, and weight. Weight would be, let's say, 12 tons, and or any other attributes we can add. Let's say year 2011. That's it. We close this node and we created. That's how we created one label. One node created with 3 properties in 10 milliseconds. If we check what we have in our, let's say, user tables or whatever in the schema, we have only truck one created. Now we can create another node. Let's call it road, and then add some attributes to it. Name for it doesn't have to be the same attributes. Could be very different type of attributes. Type would be a highway. and let's say location would be Ontario. Okay, we add the next note. What went wrong here? Road name doesn't have a column. We need a column here. Another node is created. So if we see our user tables and everything, all the schemas, there are two nodes are created. Let's change the name, change the color of this here to something different. It's looking good. Okay, now we want to add a relationship. How we add the relations? The cipher, which is the language created by Neo4j, and I'm using right now, it has a simple syntax for creating a relationship. It says first you find your two nodes, match, meaning find or select, vehicle, find the vehicle. We add a pointer to it, which is V. I'll tell you why we do that. We find the vehicle that its name is truck 1. Okay, that's enough because there is only one name with truck 1. Let's see if it finds it. Return R V. We already added a pointer or a name for this. It finds it. Okay, now we also find comma, another node we need to find in order to add a relation between them. What is another node? Another node is road. Road is already there listed. The name should be 401. Name 401. Okay. And then that's a second one is also matched or selected. Let's see if they found it. Return comma or find these two nodes for us. Yes, it is found, no problem. Now what we want to do, we don't want to only find, we want to merge them with a relationship. Relationship is as simple as the graph. Imagine we want to create it in a ASCII code kind of thing. Is the same thing. So vehicle connected to, and the relationship are by created with a square bracket instead of round bracket that are for nodes. Only we have these two types. And let's call this relationship runs, running, or runs on 401. 401, which is, we have already selected it, we named it R. Okay, so we are creating a new, we are merging these two or creating a new relations between V and R, and V and R are clear what they are. Let's see what now we have. Let's now return them, see the two nodes. The two nodes are connected with a runs on relations. These are as simple as that. I have a script that creates a bunch of sensible, basically graph database with maybe 5 or 6 nodes and number of relations. I have a script for it. I cannot run the script here. I need to go to my Linux and run a script from there. Okay. So basically, what I've installed here is the let's clean this. What I've installed here is Neo4j that comes with a client side called, let's like something C++. Is a client side called the Cipher Shell. Okay, so Cipher Shell comes with Neo4j. Let's start Neo4j. sure if I really need to do that because I'm not connecting to the my own Neo4j. I'm connecting to the one, the database on the cloud. But just in case, Neo4j is already running. Okay, so I have to run Cypher shell, but I need to make sure that it's connected to my database on the cloud. I've created that already here. Why? Because it needs a long, basically, parameter, and I'll tell you why. What is these parameters for? So we are running Cypher shell as root with sudo, and I want some extra character. Let's get rid of the extra characters. All right, so we are running Cypher shell. The most important thing is the address of this database. That's the address. This is the protocol, Neo4j plus S. That's the protocol. This is the address. The only thing we need is the username and password. Password is long, so I have copied that. There, let's connect to our client, which is Cypher shell. Now, okay, we are connected to the Cypher shell. Let's do the same thing here. At the end of every command, we need a semicolon. Let's see what we have. We have vehicle and road. That's not enough. I have a script here that let's see my script. It's called Cypher 1. Let me show you. Oh, the column exclamation mark doesn't work here. Let's get rid of that. Let's exit. Show me what on my screen my script is. This is my script. Simply remove everything, create a couple of nodes: vehicle, road, inspection station, vehicle record, defect, and then create the relations between all of these. For example, as we see between the road and the vehicle, there are two relations between the same two nodes. One is running on or is on. The other one is after inspection is back on. Okay, so these are things simple, basically script. If you want to run that, I'll go back to Cypher client. And run this. Simply we say source Cy1, we run that. Detach all the nodes, delete all the nodes, and creating all these new nodes. Okay, so now that it's created nodes, let's list them. See what we've got. Match then return in semicolon at the end, because we are at the client side. We have these nodes doesn't show the relations here, but the relations is there. Now we go back to our browser and we check. We could have done it on Linux as well, but we go back here to our browser. We now say match turn in. Let's see what we've got after running that script. Okay, so this is what we've got. the defect, the records of a vehicle, of a commercial vehicle. A vehicle was running on 401, and then the vehicle got pulled one direction. Why this is? Yeah, it got pulled into a station, then which was a station was located on 401. Then the vehicle was diagnosed with a defect, and this defect was detected at this station. After the defect, it goes to the record of the vehicle, and then the vehicle, after repair, Mr. Repair node, is back on for to create the meaning for the data, or data about data, or metadata. The knowledge graph these days are trendy. A lot of organizations going creating their knowledge graph, the metadata, in the way, and to show how the nodes and arrows are related to each other. Make that, and then make those knowledge graph actionable in terms of connecting to the real data. Another pillar of the data fabric is the data-driven culture. The data-driven culture is about involving more and more people as it is possible to enrich the meaning of the data, and to make their activities and decisions based on data and based on evidence as much as possible. Encourage more employees to learn data handling techniques and get the data basically skills not out of the limited number of elite data analysts and data engineers. This way we can really make use of our data. Now, another subject is, where is our data? This is very important one. Where is our data? Is it only the production system where the data is being produced and downstream in the data warehouse? Yes, but there are a lot more to it. Our data is not only there. Our data is in the PDF file, in the spreadsheets, in the mind of people, in the code itself, the entity name, class names, their class hierarchies, the interface, class interface names, all those things. Let's